Hi guys, it has been quite a long time since my last video about CNC machines. A few days ago, I got an email from the same vendor who provided me the 30-inch CNC Pro set that I used in my instructional video on how to start using this type of machines. The vendor really appreciated all the feedback that I gave last time, so they decided to launch a new 30-inch CNC Pro kit that is more complete, safer, and more user-friendly for any beginners. They wanted me to be the first to test this kit and also get back to them with suggestions to improve this machine. This new version should include the limit switches and features to install them, an e-stop button that will help saving your machine in case things go wrong when cutting, a touch probe that will help zeroing the Z-axis, a 5.5 watt laser that I think really fun to use, and I will try to show a good project with it at the end of the video. I will fast forward through the unboxing and assembling of the machine. I will slow down when installing the new features. So let's get started. Look at this, they include the cable wrap that I suggested last time, limit switches, e-stop button, touch probe, look at this, they really listened to my suggestions. They even include the zip tie and some cover for the aluminum extrusions. On these two bars, here are the slots to install the limit switches. Next step, I will install this e-stop button. I will install it on this side where there's a knob here to move the x-axis manually. I will install it in this hole, so this way I will have more space to push the button in case of emergency. On the other side, the stepper motor is a bit more bulky compared to this button, so there will be less access compared to this side. So I just unscrew this, slide the button through here, and tighten the plastic nut. That's it. Here on the controller, this is the connector for the e-stop button. I just click it in here. Okay, so the red wire is connected to the C pin, and the black wire connects to the normally open. And that's it, the e-stop button is connected. This is a touch probe, just come with the machine. On the other end is the connector for it. I will connect it to the pin A5 here. That's it, the touch probe is connected. Next step, I will try to install the limit switches. I hope that you can read the print on here, Z limit. So this one is for the Z axis. As you can see here on the side of the Z axis, there are two threaded holes to install the limit switch. I will take the bolts out and fix the limit switch here. And these two holes here is for the lower limit switch of the Z axis. I will take a small zip tie and tie the wire here. Same thing for the other cables, X limit, Y limit. So this one is for the X axis. I will use this to install the limit switch on the X axis. Here there are two slots to fit the bottom of those pins in. So the installation of the limit switch is directional. It is very sturdy, a lot better compared to hot glue gun just I used last time. The limit switch on this side click OK, but I have this cable here pushing on the connector of the limit switch. So I don't think that this is the way to arrange the wire for the Z-axis limit switch. What I will do is that I will run it through the back of the Z-axis block. This way the wire will run down here and it won't hit these wires. I won't have to rearrange the wire because if I tied it here, the wire won't be too short and I won't be able to connect it to the control board. I retie the wire on this side, this way I can easily connect it to the controller board. Maybe I should move the controller board to the middle of the machine here. Now for this wire connecting between the two limit switches on the X-axis, I will slide it into the slot of the aluminum extrusion bar at the back here and use one of the slot cover that they provide to snap it in here. This wire, I just run it through the back and connect it to the controller board. There is a slot here to install the limit switch on the Y-axis at the front and at the back. At the back, I just plug the connector into the controller board as marked here. Next step, I only need to connect the wire for the spindle and all the stepper motors. All the cables for the stepper motors are of the same length, so I don't need to worry which one for which. And that's it, the machine is now all connected. Next step, I will try to arrange all the wires so the machine looks neat and tidy. I just press the cable tight in here and tape it down with some duct tape. Just like this, and it is really neat. Next step, I'm going to try to configure and test all the new features of this machine. Actually, I'm going to test the machine with the offline controller first. Okay, I will go to control and move the x-axis. Y-axis, Z-axis. I click on the Z plus button too long and the Z-axis move all the way up, hit the limit switch, but the machine didn't stop. I think that the controller board wasn't configured for the limit switches, so I will try to do that on the computer. The spindle also turned in the reverse direction, so I will swap these two wires. There is a power button at the back here, so to turn it on or off, I just press it. Turn the machine back on, turn on the spindle. It's good now. Now to test the e-stop button, I will try to move the x-axis really long, and then I will press that button. It stopped, so the e-stop button worked. I cannot move the machine. I will release this button. After release that button, I still couldn't move any axis. So I think that I will need to reset this by repower this machine, or I will have to connect it to the computer and disable all the alarms. At least for now, I know that the e-stop button works. Next step, I will configure all the limit switches on the computer and also this touch probe. Let me show you what's included in the USB drive that comes with the machine. All these folders here are manuals and instructions. I will ignore them for now. If you are a first-time user, maybe you should take a look at them first before starting anything. I will go into more details on this folder. Grbl and laser software. Driver for the controller board, if you haven't installed it yet. I already did that, so I will skip it for now. GRBLControl candle 1.1.7. I already installed it on my computer right here, so I will also skip it. I wouldn't use any code in this test code folder because, as I explained to many viewers, I have no idea about the parameters used in these G-code files, like the type of bits, thickness of the stop, points of origin, type of tool path, feed rate, etc. If you are a beginner, please have a look at my other instructional videos on how to start using this machine and practice with the process of generating the tool paths and G-code files. You won't be able to use other people's G-code on the machine. Let's move on to the next folder. Laser software. I will try to install this software. I will launch it. It suggests you to update the software. I will click on download. Launch it again. Here's the interface of the software. I haven't plugged in the machine yet because I haven't set up the laser, but let me just try to open an image for laser engraving. In the laser software folder, there's a picture folder. I will click on one of them. This is one of the logos that they have. Few of the simple settings that you can use to process the image. Sharp or smooth. I will choose smooth. Brightness, well, black and white. You don't need really brightness. Contrast either. White clip. Yeah, not much change here. Black and white. You can unclick this. It will be really smooth. Type of conversion tool, line to line tracing. 1 bit black and white dithering. As you can see here, there's a lot of dots. The laser will engrave dot by dot. This will make the laser only engrave the outline. Center line, interesting, only these lines. Pass through. Well, I think I will choose line to line tracing. Horizontal tracing. Quality. I will increase this. Probably at least 5. So this will equal to 200 micron resolution. Click next. You can choose the engraving speed. You will have to experiment multiple times to find the right speed. Laser mode. Constant power. If you only have like black and white like this. If you have a gray mode picture, I think you will have to choose the dynamic power. For this one, I will choose constant power. S min 0%, S max 100%. Auto size. If you click on this, you can choose the resolution of the image. I'm not sure how to do this, but I think 300 dpi is normal. So I click create. I cannot really change much now. So from here, I think that I can only click the button to launch the engraving. But I haven't plugged in the machine yet, so I'm not going to do that. Compared to other software that I use is LightBurn. It's a shareware that you have to pay $30, but I think it's totally worth the price. You will have a lot more flexibilities in choosing the settings, position, dimension of the pictures, the mode to engrave, power. It is a lot easier to test and find the right parameters. I will show you quickly how I use LightBurn later in the video. Now I will connect the machine to the computer. Open GRBLControl. I will go to Service, Settings, through the port. I think it might be COM8. Click OK. Maybe not because the version of Grbl is not shown here. So let me just choose again. COM3, I think. Yes, the Grbl is 1.1F. I will type in $. It has been so long time since I used Grbl, so I will check on their website to see which one to enable the limit switches. $21 is hard limits. I will turn it to 1. Right now it is $0.21 equal 1, and double dollar sign again. Yes, it turned to 1. Now I will turn on the machine and try to move all the axes. As you can see that the Z-axis stopped the moment the limit switch is clicked, so they are enabled and working right now. Let me just try all the other axes. On the computer you have the message reset to continue, so I click here, reset, unlock, move the Z-axis down, reset again, unlock, move it down. Okay, I will try the X-axis. It also worked correctly. Next step, I will set up the homing cycle. Homing cycle will be $22. This I will see later. I think this I can increase it a bit. $24. I think I will keep it at 25 millimeter per minute. $25. I think I will increase it to 1,000 so it can home faster. Let's say 2,000. It will be very fast. Homing debounce, I will leave it at 250 milliseconds. Homing pull off, I will put 2 millimeter. Now I will click on the home button to see how the homing cycle works. First thing I notice is that the homing cycle worked correctly this time, so the limit switch between the X-axis and the Z-axis are not inverted like the old version. As you can see right now, the machine home at the top of the Z-axis, on the right corner of the X-axis, and the front of the Y-axis. I wanted the X-axis to home on this side. I will invert the mask for the X-axis. So $23. Right now it is 0. Let me check which number I should use to revert the X-axis. Okay, so I want to invert the X-axis. This is the first one here. First bit will be X, second bit will be Y, and the third bit will be Z. Right now I only need to invert the X-axis, so I will put $23 equal 1. I will move the Z-axis down. I will move the Y-axis too. Perfect, it worked as expected. Now I will reverse the Y-axis also. I already invert the X-axis, now the number is 1. I wanted to invert the Y-axis, I will have to change this bit to 1. So the number will be 3. $23 equals 3. Move the Z-axis down. Move the Y-axis. Move the X-axis. and click on Home. Now the homing cycle is working correctly, but one thing that I noticed is that right now all the axes are at the limit, but on the y-axis, the edge of the plate here is really far away from the spindle, so I would have to move this whole block forward. Loosen the bolts on both sides. I slide the whole block forward. Now what I will do with that, I will measure the distance from here to here, and I will have to fix the other side at the same distance. Actually, I will move the z-axis down so you can see better. So the center of the spindle is about right here at the edge of the platform. I will fix this side a little bit, not too tight. I will do something very simple. I just use my square, press it on the table, press this edge here, and push the ruler all the way until it touches this edge. And I lock the square. Now I will switch to the other side. Now I will push this edge to this edge, like this, and push this block back, like this, and tighten the bolt. Next step is to set up this touch probe. The height of this touch probe is a bit too much, 20 mm from the bottom to the top here, so we can only use this probe on very thin stock because the working range of the z-axis is 45 mm minus 20 mm of this probe. You only have 25 mm left, minus also the sticking out of the bit from the spindle, so we will have very limited thickness to work with. This is the Z probe button. I will go to Service, Settings, and modify this probe command here. Okay, in here I just realized that this is the probe sequence that I set up before. So let me just explain this sequence very quickly. G38.2 is the probe command. It moves the z-axis down with the maximum range is 30 mm. Feed rate is 100 mm per minute. Once the bit touches the probe plate, it moves the z-axis up 1 mm. Then it will run the probe command again with the maximum range is 2 mm. Feed rate 10 mm per minute. Once the bit touches the probe plate again, you will set the height of the z-axis at the value that you entered. Right now it is 1.6 mm. I will modify it to 20 mm. After that, the z-axis will move up 3 mm from the touch plate. So I click OK. Let me try to run the probe sequence. I will use this piece of cardboard as my pretend stock. I will use one of the V bits that come with the machine. G90Z0. I think it is perfect this time. And that's it, all the new features of this machine work correctly. Next step, I will try to make something with this machine. I will try to make a cool looking coaster so I can put my cup of beer on it. I will start with Fusion 360, create a new sketch. Circle. The diameter of the part to hold the cup will be 90 mm. I will make this edge about 10 millimeter. Extrude this part. I will make it our birch plywood, 1/8 of an inch thick, so 3.125 millimeter. I will save this part first. I will go to manufacture, create a setup, origin. I will say 5 millimeter offset on the side. Zero on top. Click OK. For this string, I only need to use two simple 2D contour. Select the tool. I will use the flat end mill, 1/8 of an inch diameter. For the 2D contour, I will go very slow, 500 millimeter per minute. Contour selection, I will start with the inner contour first. I will use some tab, rectangle, tab width, tab height. I will put 1.5 millimeter just to be safe. I will reduce the number of tabs. And like this will be fine. I will reduce this to 4, 2, 1. Bottom high with minus 0.5 millimeter. So it will cut all the way through the stock. Multi-depth. So the machine will use 2 steps down to cut this ring. Safe distance. Maybe I put 3.5. It seems too small. Maybe I put 5 millimeter. Okay, so it might be the other way around. I will reduce this. Okay, let me just check again. You know, 1 millimeter. Yeah, that's fine. Okay, lead in. I just leave it like this. Lead out also. Nothing to change here. So I click OK. Everything look correct to me, so I will cut the other ring the same way. Duplicate. Edit. Delete this contour. Choose this contour. And click OK. That's it for the first part. I will export this. Okay, I would have to change the first processor to Grbl. Grbl/Grbl. Save retract G28. This command will home the Z-axis. I already enabled the homing cycle, so I will leave it like this. Click on post. I will name it coaster ring. Next step, I will create the bottom part. So the outer ring will be 110 millimeter. This one I only need to cut it out using the 2D contour, and to make it very simple I will reuse the 2D contour of the other ring. So I will only need to use this contour. So I just post-process, push the bottom, and that's it. I will have two parts of the coaster. I will glue them together later once I cut them. So let me just prepare two pieces of plywood and show you how the machine will cut them out. I actually prepared three pieces. One will be the wasteboard and the other two will be the stocks. This one on the bottom will be the wasteboard, and I just lay other piece on it like this, stack them up. I will use the stock clamp that they provide with the machine. I like the design of these clamps very much, so I made my own version for my other CNC machine. The stock is fixed very sturdily on the platform. Here is the bit that I will use, single flute flat end mill. On the computer I just open candle, file, open, coaster NC, coaster ring. I will use the touch probe to zero the z-axis. And that's it. I just click on send. The machine suddenly stopped. I had no idea what happened. So let me just replace the stock and try to run it again. After two failed trials, I did some changes on the computer. I think that it should be working now. Let me just try to run the test again. You will find that the solution is really crazy. As you can see that it will cut smoothly. Now let me show you what is the solution. The source of the problem is that kind of software is kind of a diva. You only want it to be on the main stage. If you are using a computer that have two monitors like mine, make sure that candle is opened and closed on the main screen. If you open candle for the first time on the main screen and drag it to the second screen, the error will happen. And if you close candle on the second screen, you might have hard time to open candle again. If you don't believe me, try it for yourself. That was the only thing that I changed to make this work. Here's how I did it. So first of all, I just right click on my screen, display settings. As you can see that I have two monitors. When I first started, I set the monitor number 2 with the main screen. So that didn't work, as you can see. So now what I did is that I choose this screen, and I click on make this my main display, and that's it. I close this. Now I can open candle very easily every time. Now let me just drag this to the second screen. You might not be able to see it because I don't have the recording on the second screen. I drag it here, close candle. I will try to open candle again. Now as you can see that nothing showed up. You cannot really open candle. Let me just try to fix the problem the easy way. So I right click on this, display settings, and I click on the second monitor and make this my main display. And I close this. Now all the icons is on the other screen, so let me just open candle on that screen. Okay, and you can see that the candle is open right here. Let me just drag it to this screen. Right here, I close this. And I will try to open it again. Nothing showed up as you can see, so I have to switch back again. And here are all the icons. Double click on this. And magic, candle opened. This error is really stupid, but if you don't know it, it might make you crazy. That's it, let me just continue to cut the other parts. Again, the piece will cut nicely, no problem at all. Next step, I just glue the two pieces together. I want to use the laser to engrave something in this circle. Here's the laser motor. You have the power driver. You have the laser and the cables. They also include some screw and sliding T-nuts here to fix the laser on the board. But I forgot to slide those nuts into the aluminum extrusion, so I will use my drop-in T-nuts instead. I will use the M3 8mm bolt. Connect the cable. This is the power cable. I will take the power come out from here. The laser, it have two cables. One is the power and one is the PWM signal. The red connector is to the power right here. The white one is to PWM signal, is up here. Now I have the laser is connected. I will try to install this laser into the spindle module. The last machine they sent me, it didn't fit. This time hopefully it will slide in nicely. This time the laser slide in just nicely. So I can tighten the bolt here. But before doing that, let me just show you one of the tricks that I just think of. So what I noticed with this laser module, that the aluminum housing here, it has 4 slots here that I can thread them with the M3 tab. I will make the thread in one of those slots. That's it. I will take one of the M3 bolts about 30mm length, put on the nuts, install the bolt in the slot that I just threaded. Make sure that the bolt is sticking out from the laser head. Then I can jam lock this bolt with this nut. Now I will fix the laser in place. Next step, I will show you my trick with this bolt. This is the first time using the laser, so I won't have to focus it. I will use this piece of white paper. Place it on the stock like this. Turn on the machine. Don't turn on the power for the laser yet. I will have to change the $32 to 1. Switch it to laser mode. Change the $30 back to 1000. Now the machine is in laser mode. But what I wanted to do is to setting up the touch probe with the bolt that I install on the laser. Next step, I will go to Service, Settings, Panels, and I click on this user commands. Click OK. Now you have this menu show up. Click on it. I will have 4 buttons here from 1 to 4. I will use the button number 4. I go to Service, Settings, User Comments, and I can modify the button number 4. I will copy this, and I will modify this a little bit. Only at the end, I will lift it up about 10 millimeters, and click OK. Now I will move the laser to the middle of the paper. Right now the laser is really far away from my stock, so I will have to slide it down a lot more. It is still really far away. I will have to change this bolt to something a lot longer. This new bolt is 20 millimeters longer. This time the bolt is sticking out a lot more. I think this will be enough. I put the paper here, put the touch probe underneath the bolt, clip the alligator clip on the bolt, and click the number 4 button. Lifting up 10 millimeters probably too much. I will lift up only 2 millimeters instead. Take the probe out. Now I will open LightBurn and turn on the laser to focus it. Install it. Launch LightBurn. You can use the trial version for 30 days with full functions, so that is really nice. So I click on Start your free trial. Start my laser. Grbl 300mm by 180mm at COM3. At the port for the 3018 CNC. Click Add Device. Where is the origin of your laser? I always use front left. Auto home your laser on startup. Maybe not. Click Next. And Finish. And click OK. Next step in LightBurn, make sure that you choose the device. COM3. Now I will expand this menu. Here in the console area, we have 6 buttons like this. They are the macros. I will program them. Right click to change. I will name it Laser Focus. And I will copy and paste the probe command from Candle. Modify this one, 2, and click OK. Now I will try to run this macro. As you can see that the machine stopped right here. It didn't leap up and probe again. I think it only ran the first command. So let me just modify the macro. I will try to do this. G0 Z2. It should be like this. I click OK. Now I will run it again. Let me move this up. It works correctly this time. So next step, I will focus the laser. I will remove this probe. Here in the move tab, normally I should see a fire button here with the intensity that I can decide. And to focus, you will put it at low power. For the fire button to show up, I will have to go to Edit, Device Settings. I can click here, Device Settings. Enable laser fire button. Click OK. The button is still not here yet. I think I will have to close LightBurn. Open it again. Okay, let me go back here again. Yes, so I have the fire button, the power. Let me just try to move this. Okay, the machine is still moving. Here I will start with 2%. Like this. It will be very low power and it shouldn't burn the paper. Before I turn on the power driver for the laser, I put on the goggle just to be safe. Okay, I saw it blink. Now I will click on fire button. I see the dot here. I will start to focus it. Try to get the smallest dot as I can. I think like this will be fine. I turn off the laser. And that's it, you are done focusing the laser. For me, I even prefer to glue this knob here so it doesn't move and I won't need to focus ever again. Every time I need to focus, I just use the probe setup with this bolt and the macro. Let me try to find an image to engrave in this circle. I will try to engrave this lion face. Back into LightBurn, I just file, import the image I just saved. Now I want to make this into a circle. I draw a circle, press down Shift. I will change the color of this layer. Click on this. Make it light. Okay. Now I can move it. Make it a bit bigger. I think this is perfect. Next step, I will choose both layer, Control A. I will go to Tools, Apply Mask to Image. Now I have a round image. I only need to resize this to be smaller than 90 mm. That's the size of the circle that I have. Okay, millimeter here, I will reduce it. Smaller than 90, I would say 86. It's only reduce the mask. I think I will have to reduce the size of the image too. This is perfect. So now I can Control A, move it around. Now I have an image. I will try to engrave it as a draft. I will only engrave the image. So I double click on this. I'm just testing the laser. I have no idea which speed and power I should use. I will put 1000 here. Max power 80%. I don't like to use 100% because it will overheat the laser. So 80% will be safe. And I usually like the grayscale mode. It will make the image look much better. It just takes a lot of testing to make the image look really nice. I will use 200 micron, 0.2 millimeter. Yeah, I think that is about it. I click OK. Okay, I will turn this off. I don't want to engrave the line. You can even turn it off here. Now to engrave, I want to reference the image at the center here. The center of the circle will be the center of this image. I will try to do this. Current position, center, and that's it. I have this roughly a circle here. The center will be right here. I only want to run a draft on the wasteboard and click on start. As you can see that the draft doesn't look too bad at all. I think that I will use the same parameters to engrave this picture on the coaster. I will tape the coaster down to the wasteboard. Next step, I will have to focus the laser to this surface. I just take the touch probe, do it like this, and click on laser focus. That's it, I'm done focusing the laser. Next step, I will have to center the laser here to the center of this inner circle. I know that the diameter of this circle is 90 millimeter, so I will point the laser to this edge, move it up 45 millimeter, point the laser to this edge, move it to the right 45 millimeter. That way I will be roughly in the center. I'm roughly at the edge now. Now in console I will type in G91. G91 will tell the machine that if I want to move a number, it will move the distance from the actual position right now. So I move G0Y45 and it stopped. Now I will tell it to move to the left 45 millimeter. X minus 45. Let me try the laser. I still need to move it a little bit more. Yeah, roughly like this will be fine. Now I will tell it to move back 45 millimeter. That's it. Now I have the laser roughly in the center of the circle. I will start engraving. I won't need to change anything. I will use the same parameter. So I just click start. Now I have a really cool looking coaster that I can put my beer on. With both of the tools provided with this 3018 CNC Pro kit, like the laser and the spindle, I'm sure that you can make a lot of cool things with this machine. I should recommend you to buy this kit, not because of the vendor give me this machine for free, but because of few other reasons. First of all, this kit is really complete. It includes almost any feature that you can add on, like the reset button, the limit switch, and the touch probe. And for all of that add-on feature, the price didn't change compared to the last kit. Compared to all the other kits on the market with the same price, this kit have an extra feature, is the laser. The other kit doesn't include this. You will have to pay more to get this laser. And it is really fun to use, as you can see here. One more reason I recommend you to buy this kit, because this vendor takes your suggestions or complaints really seriously. As you can see that they made all the small improvement in the kit as I suggested, and I already gave them few smaller feedback to improve this machine, such as the length of the cable of the limit switch, the thickness of this touch probe, and also the type of bit that include with the machine. I suggest that they should include some more of the flat end mill bit instead of only the V bit, which is fun to use but not really useful to cut things out. Other than that, I hope that this video will also helpful by showing you how to solve problem with candle that it doesn't open when you have multiple screen computer, and also how to focus the laser consistently using the touch probe. That I think is really helpful because it will save you a lot of time focusing the laser, and also the focus of the laser will be consistent every time you use it. That way you don't need to spend much time playing with the speed and power of the laser when engraving or cutting. Of course, this is a good kit to learn CNC machine, but it's not a powerful machine. So don't expect that you can buy this machine and use it on some really hard material like aluminum or steel. And also this machine is quite slow, it's not really powerful, so you cannot really use this for a business. You can use it for fun or prototyping. I'm saying this because I got insulted by some viewers who asked me to try this machine on steel, and I refused because I know that this machine doesn't work on the materials. And they got so angry that they called me all type of names that's, well, you don't want to hear it. And that's it for this time. I will try to come back more often with CNC machine videos. And of course, cheers.